In this lecture, we are going to discuss about convolution theorem. So we know that the convolution theorem for Z transform states that for any real or complex signals, the convolution in the time domain is the multiplication in the Z domain. So for example, we have the signals X and Y. So its convolution of this signal is the multiplication of its respective Z domain signal. Okay. So X convolution of Y tends to X into Y. So here X is the Z transform of X and Y is the Z transform of Y. So we can say that the convolution of the signals X and Y is equal to the multiplication of its signal in the Z domain. Okay. So here the Z transform of X and Y equal to X of Z into Y of Z. So X of Z is the Z transform of X and Y of Z is the Z transform of Y. So now we are going to see the proof. So here Z transform of X and Y, XY equal to, so here we know that the standard Z transform definition sigma n equal to 0 to infinite X into Y, X of n Z power minus n. So this is the standard equation. So instead of X we are writing X into Y. So this is the convolution of this signal. According to the convolution property, so we are writing sigma n equal to 0 to infinite. Here instead of X into Y, the convolution of this signal, we can write sigma m equal to 0 to infinite X of m into Y of n minus m. This is the convolution of X into Y. We can write X into Y as sigma m equal to 0 to infinite X of m into Y of n minus m into Z power minus n. So this is the same. Again, first we are writing sigma m equal to 0 to infinite first. So X of m we are taking here. And the remaining terms are sigma n equal to 0 to infinite Y of n minus m into Z power minus n. So look at this equation. So this is the Z transform of the signal. So this is the Z transform of time shifting signal. Okay. So Z power minus m into Y of Z. So instead of this we can write Z power minus m into Y of Z. So sigma m equal to 0 to infinite X of m into Z power minus m into Y of Z. So for this equation we are writing Z power minus m into Y of Z. This is the Z transform of this sequence. Next, sigma m equal to 0 to infinite X of m into Z power minus m X of Z. So it's the standard Z transform definition and Y of Z. So finally we can prove the Z transform of X and Y equal to X of Z into Y of Z. So the Z transform of convolution of this signal equal to the multiplication of their respective Z transform. The multiplication of signals in Z domain. Hence the convolution theorem is proved. Okay, thank you.